Everyone's comparing benchmarks, MMLU scores, coding leaderboards, context window sizes, and look, that stuff matters if you're picking a model for a specific task. But here's what most comparison videos skip entirely: why these models behave so differently in the first place. And the answer is architecture. So, in this video, we are not going to talk about GPT versus Gemini versus Claude because honestly, the details of those models are almost entirely closed off. OpenAI, Google, Anthropic, none of those OpenAI, Google, Anthropic, none of them publish architectural details for their frontier models anymore. What we do have is the foundational design decisions these companies made early on. And those decisions, they still shape everything about how these systems work today. So that's what we are going to get into. So all three of these models, GPT, Gemini, Claude, they are built on the transformer architecture. You must have already read about the paper, attention is all you need. So if they are using the same foundational mechanism, why do they feel so different? Because transformer is more of a skeleton than a blueprint, and what you build on top of it, how you train it, what data you feed it, what objectives you optimize for, that's where the real divergence happens. Think of it like this: all three companies took the same Lego base and built completely different things. So let's go through each one. GPT's design is almost brutally simple, and that simplicity turned out to be a superpower. OpenAI went all in on the decoder only transformer. So, what does that mean? It means that the model reads tokens left to right, and at each position, it predicts what comes next. That's it. So, no encoder, no bidirectional attention. Just given everything before this point, what's the most likely next token? The reason this matters is that it scales incredibly well. The GPT-3 paper, which is where the architecture really went mainstream, showed that if you just throw more parameters, more data, and more compute at a decoder only model, performance keeps climbing in a way that's surprisingly predictable. So that predictability is actually what led OpenAI to bet so heavily on scaling. They weren't guessing, they had the scaling laws to back it up. Now, pre-training alone gives you a very capable model that's also kind of unpredictable. It'll complete text in whatever direction seems statistically likely, which isn't always what you want. So OpenAI introduced something called RLHF, which means reinforcement learning from human feedback, and this became the industry standard alignment technique. Here's how it works. You take your pre-trained model, have human raters rank different outputs, train a separate reward model on those rankings, and then use that reward signal to fine-tune the language model via PPO. So PPO is called the proximal policy optimization, and the result is a model that's much better at following instruction and producing helpful outputs. But there is a trade-off as well. RLHF can be unstable and it requires a lot of human labeling, and there's always a risk of reward hacking, where the model learns to game the reward signal rather than actually being helpful. This is a known limitation that both Google and Anthropic designed around. Here's where Gemini takes a fundamentally different design philosophy. GPT was built as a text model first, multimodal capabilities were added later on. Gemini was designed to be multimodal from the ground up. So, what does that actually mean architecturally? When Google trained Gemini, they didn't train a text model and then add image understanding on top. They trained a single unified model on text, images, audio, and video simultaneously. So the model learns cross model representations from day one. The practical implication of this is that Gemini isn't just processing an image and a text question separately and then combining the outputs. It's reasoning across modalities in a way that's more deeply integrated. Now, it's worth noting that the full architectural details for Gemini are proprietary. So, what Google has published is the high level design philosophy, which is this: one model, many modalities, trained jointly. One architectural detail that Google has hinted at for Gemini, and this is consistent with where the whole field is moving, is mixture of experts, or also called as MOE. So here's the intuition. Instead of every parameter being active for every input, you have a router that selects which subset of expert networks to activate for a given token. So you can have a model with hundreds of billions of total parameters, but only activate a fraction of them at inference time. The result, you get the capability benefits of a massive model without proportional compute cost. GPT-4 is also strongly suspected to use MOE based on some leaked information, but neither OpenAI nor Google has confirmed that exact configurations. The point here is that the raw parameter count is increasingly a misleading metric. Active parameter count at inference is what actually matters for cost and latency. Claude takes a different approach to alignment than RLHF, and this is probably the most architecturally interesting design decision Anthropic made. It's called the constitutional AI or CAI. The core idea is that instead of relying purely on human letters to label what's harmful and what's helpful, Anthropic gives the model a set of principles, like a constitution, and has the model critique and revise its own outputs according to those principles. So the alignment signals comes from AI feedback rather than purely human feedback. This approach, often called as RLAIF, also called as the reinforcement learning from AI feedback, reduces dependence on human labeling at scale. Anthropic's argument is that this produces more consistent alignment because you're not dependent on the variability of individual human letters. The constitution includes things like be helpful, harmless, and honest, but operationalized into specific concrete principles the model can evaluate against. One thing Anthropic invested in early, and this is visible in Claude's behavior even today, is long context understanding. Claude's context window have been consistently among the largest in the industry, and more importantly, the model is trained to actually use context effectively across long documents rather than just technically accepting long inputs. This required specific architectural and training decisions across attention mechanisms and positional encodings that can generate two long sequences. The practical implication is that if you give Claude a 100-page document and ask it a question about page 3 that requires synthesizing information from page 87, it tends to handle that better than models that were optimized primarily for a shorter context. So this isn't a magic, it's a deliberate training priority. So let's put it all together. GPT, decoder only transformer, RLHF alignment, multimodal added iteratively. Core priority is scaling loss and general capability. Gemini, it's natively multimodal from training, likely MOE at scale, and Google's strength in cross-model reasoning built in from day one. Claude, constitutional AI for alignment, RLAIF reduces human labeling dependency, long context understanding as a first-class design goal. Now here's a key takeaway from this table. None of these is objectively better. They made different bets based on different beliefs about what would matter the most. OpenAI bet on scaling, Google bet on multimodality, Anthropic bet on alignment and safety as a competitive differentiator and not just an ethical obligation. So, how do you actually use this? If you are building something that needs broad general purpose reasoning and want the deepest ecosystem of tools and integrations, GPT is still a default choice for a reason. If you are building pipelines that involve images, videos, or audio at scale, Gemini's native multimodal training is a genuine architectural advantage, not just a marketing claim. And if you're building something that processes long documents like legal contracts, code bases, research papers, or if alignment and predictable behavior is a hard requirement for your use case, Claude's design choices directly addresses that. So these aren't just options, they are downstream consequences of the architectural decisions we just walked through. Here's the thing about frontier AI development. The specific model versions are going to keep changing. The latest models of Gemini, GPT, and Claude may come out every 6 months or so. But the foundational architectural bets these companies made, those compound. They are still visible in every new release. So understanding why these systems were designed the way they were is way more durable knowledge than memorizing benchmark scores. So if you want to go deeper on any of these pieces we covered, like the transformer itself, how attention actually works, or how RAG pipelines interact with long context models, I've covered all of that on the channel. Links in the description, and if this kind of engineering breakdown is useful to you, subscribe because this is exactly the kind of content I'm making here. Thank you.